Hello viewer, welcome to my channel Learn Physics.
व्यूअर्स आज इस वीडियो में हम साइलैब में एक प्रोग्राम लिखेंगे टू सॉल्व सिस्टम ऑफ नॉन होमोजेनियस linear equations using Gauss elimination method. Consider n non-homogeneous linear equations as given below. Here coefficients of x1, x2, x3, xn on left hand side of above equations are written as matrix A and right hand side is written as column matrix C. In Gauss elimination method, this matrix A is transformed into a triangular matrix B using suitable raw operations, and elements of column matrix C are modified accordingly and stored in column matrix D. In this method, triangularization is achieved by eliminating x1 from equation 2 to equation n, then by eliminating x2 from equation 3 to equation n, then by eliminating x3 from equation 4 to equation n, and so on till product of xn and its coefficient is left in equation n. Let us take a general case of three non-homogeneous linear equations to understand how this method works. Consider three non-homogeneous linear equations in three variables x1, x2 and x3. Here we have three equations, equation 1, 2 and 3, and corresponding matrices and the augmented matrix. In order to eliminate x1 from equation 2, multiply equation 1 with minus a21 and divide by a11 and then add resultant equation to equation 2. Replace this equation 2 by this final equation 2a. Here in equation 2a, we denote certain expressions by different symbols and rewrite equation 2a. Now in order to eliminate x1 from equation 3, multiply equation 1 with minus a31 and divide by a11 and then add resultant equation to equation 3. Replace equation 3 by this final equation 3a. Again, in equation 3a, we denote certain expressions by different symbols and rewrite equation 3a. To eliminate x2 from equation 3a, multiply equation 2a with minus a prime 32 and divide by a prime 22 and then add resultant equation to equation 3a. Replace equation 3a by this final equation 3b. Again in equation 3b, we denote certain expressions by different symbols and rewrite equation 3b. If we denote coefficients of x with different set of symbols, then we rewrite our equation 1, equation 2a and equation 3b. Now with back substitution, x1, x2 and x3 can be calculated. From equation 3b, x3 can be calculated. Then from equation 2a using x3, x2 can be calculated. Then from equation 1 using x3 and x2, x1 can be calculated. Similarly, for n equations, xn and xk can be calculated where k is from n-1 to 1. Now let us take one example to implement this understanding. Consider following non-homogeneous linear equations in three variables x1, x2 and x3. From these three equations, we can make matrix A and column matrix C and the augmented matrix. To eliminate x1 from equation 2, multiply equation 1 with minus 5 and divide by 1. Add resultant equation to equation 2 and name it equation 2a. From these three equations, we can make corresponding matrix A and column matrix C. To eliminate x1 from equation 3, multiply equation 1 with minus 2 and divide by 1. Add resultant equation to equation 3 and name it equation 3a. Now to eliminate x2 from equation 3, multiply equation 2 with 2 and divide by -9. Add resultant equation to equation 3a and name it equation 3b. From these three equations, we again construct matrix A and column matrix C. Now with back substitution, x1, x2 and x3 can be calculated. From equation 3b, x3 can be calculated. Then from equation 2a, using x3, x2 can be calculated. Then from equation 1, using x3 and x2, x1 can be calculated. Let us write a SCILAB program to solve following non-homogeneous linear equations using Gauss elimination method. तो चलिए व्यूअर्स प्रोग्रामिंग स्टार्ट करते हैं. वी हैव ऑलरेडी डिफाइंड अवर ऑगमेंटेड मैट्रिक्स. इसको डिस्प्ले करते हैं. ए कॉमा डबल कोट्स में लिखेंगे ऑगमेंटेड मैट्रिक्स. नाउ वी राइट स्क्वायर ब्रैकेट n comma m is equal to size a. We store matrix A in B also. So we write B is equal to A. Now we start a for loop for A is equal to 1 to n minus 1. We start another for loop. I is equal to k plus 1 to n. And we start another for loop here for j. J is equal to k to m. Here we write b I comma j is equal to minus a I comma k divided by a k comma k multiplied by a k comma j plus a I comma j. Here we write a is equal to b, and here we write xn is equal to b n comma n plus 1 divided by b n comma n. Now we start a for loop for I is equal to n minus 1, decrement of minus 1 and final value 1. Here we define a variable s is equal to 0. We start another for loop. J is equal to I plus 1 to n. I plus 1 to n. Here we write s is equal to s plus b I comma j multiplied by xj and now we write xi is equal to b I comma n plus 1 minus s divided by b I comma I. That's it. Now we display. डबल कोट्स में लिखते हैं वेरिएबल्स आर we start a for loop here for I is equal to 1 to n m printf backslash n x percentage d is equal to percentage 2.2 f comma I comma x I. Now we execute this code. So this is how, viewers, Gauss elimination method can be used to solve non-homogeneous linear equations in SCILAB.
व्यूअर्स, आज के वीडियो में इतना ही। उम्मीद करता हूँ कि वीडियो आपके लिए हेल्पफुल रहेगा। थैंक्स फॉर वॉचिंग दिस वीडियो। प्लीज़ वीडियो को लाइक कीजिए, शेयर कीजिए और मेरे चैनल लर्न फिजिक्स को सब्सक्राइब कीजिए। थैंक यू।